Okay, since we got you guys here now, just a note, Thursday I will not be here for this class.
On Thursday.
So Thursday's the day you don't have Rick before me, right?
No, that's Wednesday.
That's Wednesday now? It changes every semester.
Wednesdays we have math first in the morning. But
Okay.
Thursdays we have
I thought maybe it was Thursday, so you guys get an extra 2 hours sleeping in.
so no class on Thursday.
No class for me on Thursday. So maybe if you mention it to Rick, I don't know if he'll adjust his schedule for you
Okay.
or not. But yeah, I have to be in Shell Lake for meetings all day on Thursday. I'll be here for my first class at 7:30, but I gotta leave at like 7:10 to get out of here.
I'm sure he won't mind it after an hour or two of sleep.
Well, yeah, I don't know if he could push his class back an hour for you guys or what. But tell him he can have my hour.
All
Okay, so the problem I'm going to pose to you today is I'm going to tell you guys I can throw a baseball at a rate of 90 feet per second. Would you believe me? 90 feet per second.
When it first leaves your hand, or like
That's, yeah, traveling.
traveling at 90 feet per second. I would believe
That means I can stand at first base, throw the ball to home plate, and it'll get there in 1 second.
I would believe that.
You would believe it?
I would believe that.
Mark, what's your vote? You're looking like a no comment there.
I don't know. I know it's humanly possible.
But is it me possible? It is humanly possible.
I think
Well,
it could be
is that fast?
possible. No.
90 feet per second. Well, what are we used to speeds being expressed in?
Miles per hour.
Miles per hour. So let's convert that to miles per hour. 90 feet per second is 90 feet over 1 second. Now we need to change feet to miles. So let's do that. Feet are on top here, so I'm going to put them on bottom so they'll cancel. So I'm going to change it to miles. So 1 mile is how many feet? 5,280. Now the feet have canceled out. We now have miles per second. I want to get rid of seconds. Where am I going to put seconds here? On top, because they're on bottom here. By putting them on top, they'll cancel. Now, I don't have a direct link from seconds to hours, so I'm going to go from seconds to minutes. What's my relationship between minutes and seconds? 1 minute is 60 seconds.
Why couldn't you just go straight to hours?
I'm making a point. You could if you knew it was 60 times 60 is 3,600 seconds in an hour. So now we're in minutes. I want to get rid of my minutes. So I'm going to put them on top and go to hours. So 1 hour is 60 minutes. And yeah, you're right. From here on out, now that I know it's just 60 times 60, I know there's 3,600 seconds in an hour. I would probably just use that instead of doing it step by step like this. So now on top here, I have 90 times 60 times 60, which is what, 324,000 miles? Over on bottom, I have 1 times 5280 times 1 hour. So 5,280 hours. So theoretically, if I throw a baseball at that speed, in 5,280 hours, it'll go 324,000 miles. So it'll go around the equator 20 times in 5,280 hours. Well, if we divide that out, what do we get? $61.36. 61, not 51. You don't think I can throw it 60 miles an hour? I bet I could still throw 60. If I warmed up, I bet I could probably still throw 60, 62, 63. In my prime in high school, I was throwing just low 80s. That was a long time ago. That was 25 years ago. I said I could probably only throw maybe 3 or 4 of them at 60 miles an hour before my shoulder would start to hurt. But for a while.
I pegged you as a band.
No. Oh, I did play in the band. But yeah.
You look like a clarinet player to me or something, you know, just a little bit out there.
Okay, so then our next example, what we're looking at here with these dual units is being able to convert not only the top unit or the bottom unit or both, as we did in this example. So let's say we have something like 42 pounds per square foot. And I want to know what's that going to be in pounds per square inch. So this is 42 pounds over 1 square foot. Do I need to change the pounds? No, I want to keep pounds in my answer. What I need to change is the square feet. So it's on bottom, so I'm going to put square feet on top of my conversion factor. What's going to go below it? Change the square inches, right? What's the relationship between square feet and square inches? Which one's bigger? Square feet. So that's going to be 1. How many square inches in a square foot? Don't say 12. By 12, remember? 144. So the square feet cancel out. This is going to be 42 pounds times 1. This is 1 times 144 square inches. So it's 42 divided by 144. 0.292 pounds per square inch. Does that make sense how I'm doing that?
Yeah.
Okay. So how about if I have a pump that can pump, oh, let's see here, 12 CFM. And I want to know what is that going to be in gallons per minute. What's CFM mean? Cubic feet per minute. Do I want to change the minutes? No, I want to change the cubic feet. They're on top, so I'm going to put them on bottom. And I'm changing it from cubic feet to gallons. 1 cubic foot is 7.48 gallons. Your sheet says either 7.48 or 7.5. Depends on which conversion factor they use. A lot of books do just do 7.5. So now we've got 12 times 7.48. $89.76 gallons per minute. So it's basically a 90 gallon per minute pump, which is a pretty decent capacity pump.
We found out the other day that, or at least I found out, Rick told us, the coolant in a car
Yep.
flows at 200 gallons per minute.
200 gallons per minute. So you're looking at about 25 cubic feet per minute.
Yeah. That just blew my mind.
That's pretty fast. That's
Yeah.
that's a pretty good that's a pretty good capacity there. I didn't realize.
At driving conditions, while you're driving.
So you're looking at like 2,500 RPM, 3,000 RPM, somewhere there.
2,000, I'd say tomorrow.
Yeah.
Or just like a regular 45 on a straightaway.
Sure.
200 gallons a minute.
When the thermostat doesn't, lock up.
What was the answer for that last problem we did? Sorry, I didn't catch that.
89.76 gallons per minute.
9.76 gallons a minute.
Yep. So what if I give you that it'll pump 5 cubic inches per second? Now I want to know what that is in cubic feet per minute. So it's 5 cubic inches per 1 second. Let's change the cubic inches into cubic feet. 1,728 cubic inches in 1 cubic foot. Cubic inches are gone. Need to get rid of seconds, going to minutes. 1 minute is 60 seconds. Seconds are gone. 5 times 1 times 60 is 300 cubic feet. 1 times 1728 times 1 is 1728 minutes. So 300 divided by 1728 is 0.174 cubic feet per minute. 5 cubic inches a second sounds like a lot, but it's not. 30 cubic inches a second is about 1 cubic foot per minute. What if we have metric units that we're using here? Let's start out, let's say you are going at a rate of 1.2 kilometers per minute. Oh, it would make more sense at kilometers per hour, right? So it's 1.2 kilometers in 1 minute. Now I'm not changing the kilometers, I'm just changing the minutes. Put minute on top because I cancel out hour on bottom. So 1 hour is 60 minutes. 1.2 kilometers times 60 is 72 kilometers. 1 times 1 hour is 1 hour. So that's 72 kilometers per hour. Is that fast? It's about 45 miles an hour. 8/5 is the conversion between kilometers, and 8 kilometers is 5 miles. Yeah. Like 55 miles an hour is actually 88 kilometers per hour. What if we have let's say 12 grams per cubic millimeter. And I want to know what that is in kilograms per cubic centimeter. So this is 12 grams over 1 millimeter cubed. I need to change grams to kilograms. Now notice I'm not doing conversion factors this time because for metric we don't really do conversion factors. We move decimal points, don't we? So to go from grams to kilograms on the chart, that is 3 spots to the left, correct? So I move my decimal point 3 spots to the left. So that's 0.012 kilograms. Meters cubed to centimeters cubed. Millimeters to centimeters is 1 spot to the right, but it's cubed, so I have to go 3 times that. 1, 2, 3. So 0.001. So I divide that out. 0.012 times 0.001 is 12. One of the quirks of the metric system is 1 gram per cubic millimeter is equal to the kilograms per cubic centimeter. The same density. Let's see here. Let's say we have 3.4 milliliters per square centimeter. I want to know how many liters that would be per meter, per square meter. So 3.4 milliliters per 1 centimeter squared. Milliliters to liters. 3 spots to the left, right? .0034. Centimeters to meters. There's two spots to the left, but it's squared, so we go double that, 4. So .0001. So that is 34 liters per square meter. What do you think? Is it doable? The metric ones are a little easier. You just have to divide out some ugly numbers at some point is all. Want to see more examples, or you guys want to dive in and try them yourselves?
I'm confused on the metric part.
On the
What do you multiply to make 34?
I am taking this divided by that.
Oh, okay, gotcha.
See, .0034 divided by .0001 is 34. Any other questions? So in that packet again, page 238 is 57 through 64 is going to be doing the standard units. Page 266, 55 through 62 is going to be doing the metric units converting. We're getting really close to being done with that packet.